fairly recently a new feature has been added to the Plutus testing framework, namely that of code coverage, which allows you to see how much of your Plutus code is covered by your tests. So because the feature is relatively new, it's not completely thought through yet. So for example, if we see here, there's a function check predicate coverage, which takes this coverage reference and then, as before, trace predicate and an emulator trace. However, we don't have a function that allows us to provide both options and this coverage reference. And in our case, I needed a function like that because we do have to modify the initial wallet state. So we do need the feature to provide check options. So I ended up having to implement that myself, but I'm confident that in the next iteration, in the next version of Plutus, there will be a function like that. So if we look at the code, here at the bottom of the spec trace module, I implemented this check predicate options coverage function. So I basically just looked at the implementation of check predicate options and check predicate coverage and then combined the two. So that's this here. So the second question is, how do we use it? So what's this coverage ref we need? And coverage ref is just a new type around an IO ref of coverage report. So for those of you who are not very familiar with Haskell, IO ref is the so-called IO reference, and that allows you to do basically mutual references, mutable variables in IO. But we don't really have to worry about the details because there is a new coverage ref function that gives us such a reference. And there's also a read coverage ref function to, given a coverage reference, get to an actual coverage report. So using that, I wrote this function test coverage. So first I use this new coverage ref to get such a coverage ref. Then I want to use my check predicate options coverage, but now I'm in IO. So somehow I have to execute this in IO. So I'm using this default main that we saw earlier to run our normal unit tests. And there's another wrinkle. This default main throws an exception at the end, even if the tests are successful. It always throws a so-called exit code exception, either with exit code 0 if the tests ran successfully, or with exit code non-zero if there was a failure. That's incidentally related to what I showed you right in the beginning. In the Cabal file, there was this type of the test suite. There was this exit code IO. So that's exactly that. So that's how a testing framework signals to Cabal whether a test suite failed or succeeded by using these exit codes. Nevertheless, this interferes with the current stuff I want to do. So I'm catching this exit exception. And here in this check predicate option coverage, so I just provide the earlier options I had, the same name, and this reference I got here in the first step, and the same predicate and the same trace as before. So then I have to catch this exception, and the expected case is that there is an exception because this default main is supposed to always throw this exit code exception. So the case where there's no exception is actually unexpected, so that shouldn't happen. So normally I should be in this case, whether the tests succeed or fail. So if they succeed, as I said, exit code 0, otherwise exit code non-zero. Then I can use this read coverage ref function that I showed you in the documentation just now to get to the actual report. And then, of course, the question is what to do with the report, because if you just print it to the console, it's not very enlightening. It's just a long list of source code positions, which are very difficult for a human being to pass. Luckily, there will be a function to create a nice HTML document from that. However, that has not been merged yet with the Plutus code. So I went to the branch of a clone of the Plutus repo where this function already exists, provided by the company that Cubic that actually writes this testing framework for us, and copied the code into our repo. So if we look at the Cabal file, You see here I have this Plutus contract test coverage, report coverage. So right now it's just here. So I just copy pasted the file basically, but soon that will be part of the Plutus libraries. So then you can just use it like any other part of the Plutus libraries. Okay, so then we have this function write coverage report that takes the name of the report, and it takes this report, and it needs a so-called coverage index. And if you recall, when I showed you the smart contract in the beginning, I briefly mentioned that here. So there's this get coverage index function that takes some piece of Pluto script. And in our case with the state machine, I could just use this make TS validator and compile it and pass it to this get coverage index function, and out comes a coverage index. And with all these pieces together, I can get my coverage index. So let's look at what that looks like. If I call this test coverage function, then it will create an HTML file in the week 8 code folder. And I actually can look at that in a browser. And then we get this nice rendering of the token sale module with colors indicating the coverage. So in particular, we see that in our transition function, this has been covered, but in these guard conditions, we see this condition was always true. So this green means in all the tests, this condition was always true. And this also makes sense because in my trace, I only set the price to non-negative values, only add positive amount of tokens, only buy positive amount of tokens, and only withdraw non-negative amount of tokens. And we also see that this catch-all case here was never hit. So this means this branch of the transition function has not been covered by our code. Let's change the trace briefly and see how that changes this coverage report. So let me just comment this last step here in the trace where I withdraw. So now the withdraw transition is no longer exercised. If I reload and run this again, first of all, the test fails now, which makes sense because now, of course, the wallet value changes of wallet one are different because the withdrawal is now missing. And if I reload this coverage report here, then now we see this part, this withdraw transition is black and the code here is red. That means that this is no longer covered by our trace. So that's a very nice feature, very useful, because of course having tests is important, but obviously only if the tests actually test stuff. So you must make sure that you have as high a coverage as possible. And if a case like this happens, for example, then if there was a bug somewhere here in this part, then your tests wouldn't catch that. So it's very nice to have a tool like this. And as I said, right now I had quite a lot of work to get that working because I had to copy this code to generate HTML from this obscure branch and so on. And I had to implement this function that can accept both check options and the coverage report manually, but that will soon be available. And then it will be much easier and more convenient to actually do this. But I nevertheless wanted to show you already what it will look like because I think it's a very neat and very useful feature.